All right, so November the 18th, 2020, we're looking at example 48. This says find the coordinates of the stationary points on the curve, and the curve is defined as you see it below you. Let's see, I'll show you how I would start. I would start by first finding dy by dx. So I would find dx by dt, and this would be minus 15 plus 18 t, and I would find dy by dt, and that would be 6 minus 2t. Dy by dx would be equal to dy by dt multiplied by dt by dx. And so that would be equal to 6 minus 2t over minus 15 plus 18t. All right, so that is what dy by dx is equal to. Now, at stationary points, dy by dx would be equal to 0. So what I would have is 6 minus 2t over minus 15 plus 18t is equal to 0. All right, if that be the case, if I cross multiply, I would end up with only one value for t. So let me cross multiply. I'm going to get 6 minus 2t is equal to this time 0. When you multiply anything by 0, you're going to get 0. So therefore, 6 would be equal to 2t. Divide both sides by 2, and we would get t is equal to 3. So at the stationary point, t is equal to 3. So I'm going to say now when t is equal to 3, x would be equal to, so x is what? 25 minus 15t plus 9t squared. So it's 25 minus 15 times t, which is 3, plus 9 times t squared, which would be 3 squared. So this would be 25 minus 15 plus 81. So this looks as if it is 100 and something. It's t squared, not t cubed. T squared. So how much is this? This from this gives me what, 10? It's 91. So this is 91. Y, let's find out what y is be equal to. Y would be equal to 60 minus t squared. So it's 6 times 3 minus 3 squared. This is 18 minus 9. This is 9. So it looked to me as if the coordinate of the stationary point is going to be x, 91, and y, 9. So this is stationary point.
Sir,
Yes.
when you multiply 15 by 3, you would get 45.
Okay.
-40.
I guess I was thinking, okay. No, you're correcting it. Why never correct me from earlier? But it's a good thing. So this would have been, I don't think it's not going to make a lot of difference, but make some. 25 minus 45 plus 81. This is 61. So 61 instead of 91. I think that's the only issue. So 61. So x61, y9 is the coordinate of the stationary point. But let's do it again. So this is what I was saying earlier. Second order derivative of parametric equation, it says for a parametric equation, the second derivative can be found using d2y by dx squared is equal to, you're going to differentiate dy by dx, because remember dy by dx is going to be a function of t. You're going to differentiate with respect to t, and then you're going to divide by dx by dt. In other words, we could say d2y by dx squared would be equal to, you're going to differentiate dy by dx with respect to t. And then you're going to multiply that by dt by dx. And when you do that, you would get, when you do that, you would get d2y by dx squared. All right, let's see it in action. All right, so let me do 49, you do 50. This says, given that x is equal to that and y is equal to that, find d2y by dx squared. First of all, let's find dy by dx. So I need dx by dt, and that would be equal to 2t plus 5. Let's find dy by dt, dy by dt, and that would be equal to 3t squared plus 6t. All right, and then now dy by dx would be equal to dy by dt multiplied by dt by dx, which is sort of like the reciprocal of dx by dt. So this is going to be 3t squared plus 6t, and you're going to put that over 2t plus 5. All right, so that is dy by dx. Now, next we need to differentiate dy by dx with respect to t. So I'm going to differentiate dy by dx with respect to t. Dy by dx, and I'm differentiating that with respect to t. Well, this is a quotient, and the quotient rule says that if y is equal to u over v, dy by dx would be equal to v du by dx minus u dv by dx all over v squared. So let's differentiate. First of all, we're going to have v, which is the denominator, so that is 2t plus 5, that's v, multiplied by the differential of the top. Now, the differential of the top is 6t plus 6 minus, leave the top, 3t squared plus 6t multiplied by the differential of the bottom, and the differential of the bottom is 2, and this is all over the square of the bottom, which is 2t plus 5 square. All right, now d2y by dx squared. All right, should I simplify that? I'm wondering if I should. Maybe I should. Let's not simplify it yet. Would be equal to d dt, the first derivative of dy by dx, sorry, you're going to differentiate dy by dx with respect to t, multiplied by dt by dx. So this is going to be equal to 2t plus 5 multiplied by 6t plus 6 minus 3t squared plus 6t multiplied by 2 all over, all right, maybe I should not catch this up here. This is equal to 2t plus 5 multiplied by 6t plus 6 minus 3t squared plus 6t multiplied by 2 all over 2t plus 5 square, and you're going to multiply by the reciprocal of dx by dt. So it's going to be multiplied by 1 over 2t plus 5. All right. I think we can decide if we want to pretty it up or not. So let's pretty it up. Let's expand this. I'm going to have 12t squared plus 12t plus 30 plus 30 t plus 30 minus, and we have 6t squared plus 12t, 6t squared, not plus, it's minus 12t, because it's a negative out to the front, minus 12t, and this is all over 2t plus 5 to the third power. I hope you see why, because you have 2t plus 5 squared multiplied by 2t plus 5, so that's 2t plus 5 cubed. Up top, we're going to end up with 6t squared, because 12 minus 6 is, all right, and then this 6t got rid of that 6t, so plus 30t plus 30, and this is all over 2t plus 5 cubed. I wouldn't try to do anything more to this, so that is the answer.